So let's go over prime and composite numbers. The first number we have is 17. So what we're going to do is look for numbers that go into 17. Now 1 obviously goes into every number, right? Mm-hmm. If I were to divide 17 by 1, what would I get?
Divide 17.
By 1.
17?
Yeah, that's right. So that's technically a list of factors. So right away, I have 1 and 17. Now normally we list factors in order of least to greatest, but just to stay organized, what we'll do is we're going to list all of our pairs of factors together, and then we'll just rearrange them on the bottom. That way it's easier to keep organized, right?
Can I use a composite number?
No, let's see. Oh. Right now it's only prime, right? Because only it's 1 in itself. So let's see 2. Do you know what the trick is for 2?
Divide 5.
Well, if the number, so the number we're looking is even, 2 goes in for sure.
Okay.
Okay, is this an even number?
Yeah.
Do you remember what even numbers are?
No, it's odd.
Odd, that's right. Even numbers have to end with 0, and I knew it would do that. 2, 4, 6, or 8, and then again 0. Those are all, as long as they end with that. It doesn't matter what the tens or the hundredth column is. If the ones column ends with 2, 4, 6, 8, or 0, then it's even. So this is odd.
Wait, what?
If the ones column, so here's our trick.
Ends?
Yeah, so if the ones column, you know the ones. Yeah. So it doesn't matter what's in the tens.
Isn't the 7 in the 10?
Or hundreds. No, the ones in the tens. Here in the ones, it's a 7.
Oh.
For 2 to go in the 1, it has to be a 2, a 4, a 6, 8, or a 0.
Yeah.
Okay, so is this even?
No.
No, it's an odd number, so 2 doesn't go in.
Yeah.
The trick for 3, to tell if 3 goes in the number, is you add the numbers together. And if you add them together, and then that's a number 3 goes into, then 3 goes into it.
Oh.
So if I add these together, what do I get?
8.
Well, 8. Does 3 go into 8?
No.
No, 3 doesn't go into this. Okay. 4, I don't know a trick off the top of my head. Okay. But what I also want you to realize is, if we were to divide 4 into this, does 4 go?
No.
No. But what number does 4 go into that's really close to it?
16.
16. And 4 times what?
4.
Yeah, so that's 4 times 4. After you times yourself, you actually end up going down the row. So right now what we've done is we've tried, and I'll write them down here in red. We've tried 1, and it worked, right? 2 didn't work. 3 didn't work. 4 didn't work. And then technically, because 4, or even a better number might be even 5, but if 5 were to be times number, it'd have to be times something like this, 3 or some number in between to get to 15. So it's actually ending up going back down. So once you get to, it's called a squared number, we don't have to test anymore. So once we got the 4, we don't really have to test anymore because we know 4 times 4 is 16. Sorry, 4 times 4 is 16. So you know how 16 is really close to 17. So 5 wouldn't end up being a number. We just end up going back down this row. And you'll see what I'm talking about as we go through. So what type of number is this?
Odd number? Or a prime number?
Yeah, that's what we're really looking for. This is prime. It's only itself and 1. Okay? Let's go through B. What was the B number?
25.
25. Okay. Very first set of factors.
1.
And?
25.
Yeah, well, we set them up together. What's another set of factors?
5.
Yeah, and?
Well, 5 times 5.
5 times 5. Yeah, that's right. That works. We definitely know those. Let's quickly go through it. Does 2 go in?
No.
No. Why not?
Because that's not like...
Not what?
It's not in the... it's not like in the ones column. It's not a factor of like it's a multiple of 2.
Yeah, it has to be a multiple of 2, and it's not. Okay. 3. Add those together. What do you get?
7.
Does 3 go in the 7?
No.
No. 4. We got to test. Did 4 go in?
No.
No. What did go in?
5.
5. 5 went in. Okay. And what 5? It was 5 times 5.
Yeah.
So once we get to a mirror image of itself, essentially, like that, we don't have to go any higher.
Does every number have a factor or a mirror image?
No, they don't all do. So sometimes you have to estimate what's going to be close. They're usually called squared numbers, numbers that you can square to get it. Okay? So in this case, let's write the factors in order. What are they in order?
1, 5, 25.
Good. So what type of number is this?
Composite.
Good. So, in this one, what we're going to try to do, what's the next one?
47.
Okay, before we even start going through the factors, we're going to think of numbers that squared that would be close to 47. So there's only certain numbers like this, and this is what I'm talking about. So I'm going to write them out. For instance, if I squared 1 times 1, what do I get?
1.
Okay. 2 by 2 gives me?
4.
Okay. 3 by 3?
9.
Okay, sorry, jeez. Sorry, sometimes I think what I'm writing.
Yeah.
4 by 4?
16.
Okay. 5 by 5?
25.
Okay, are we there yet?
No.
No, so we got to keep going. And what this is going to tell us is it's going to tell us what number we essentially need to test up to. Okay? And once we start to memorize these numbers, it's going to be really easy. What's 6 by 6?
36.
Yeah, is that high enough?
No.
No, we got to get over it.
Oh, that's 7 times 7.
What's 7 times 7?
You know that. 2. 7 times 6 is 42. 49.
Yeah, that's right. Good. 49. So this number here tells us that we essentially need to test all of these terms. Because once we get to 7, see how it's a larger number?
Yeah.
Any numbers like 8 or 9 would end up being times these smaller numbers again. And as long as the small numbers go in, we know the big numbers won't work. So that's kind of like our middle point. Okay? So, does 1 go in?
No.
No?
Oh, wait. Yeah, sorry.
Obviously, right? What are its factors?
47.
And 1. Good. 2. Does 2 go in?
No.
Why not?
Because
What's that?
it's not a multiple.
What's it called?
Even number.
Even number. Yeah, it's not an even number. So 2's don't go in. Let's add these together. 4 plus 7?
11?
Does 3 go into 11?
No.
Nope. 3 doesn't go in. 4. We got to just test. So we kind of divide. 4 goes into 4 once. Down. This becomes a 0. Does 4 go into 7 evenly? No. So does 4 go in? No. 4 didn't go in. Does 5 go in?
No.
How do you know if 5 goes into a number?
If the ending, like the number is a 0 or 5.
Yeah, if the ones column is a 5 or again a 0, right? That's how we know. Just because it's a special pen right now, yeah. 6. This is how you know if 6 goes in. The rule for 2 and 3 have to work.
Oh.
So
Because 2.
yeah. So if 2 and 3 work, then 6 is going to go into that number. But they both have to work, not just one of them. They both have to work. Okay, so the 2 or 3 work?
No.
6 doesn't work. And does 7 go into this number? No. So what type of number is this?
5.
Very good.
Actually, you know that book you're reading?
Mm-hmm.
Who's the one with the autism?
Yeah.
He's talking about prime numbers. I don't know. I was really
He's probably going through them. What's the
Yeah.
last one? Let's do 48. Okay, 48. Now, quickly look down this list. What number do we have to test down to?
7.
Yeah.
7?
Why? How do we know 7's good enough?
Wait, what?
How do I know 7's deep enough? How do I know that's so long enough?
Because the number's higher.
Yeah, because it's higher. If it was lower, we'd have to go to the next one. Okay? So, we got to test the 7. Does 1 go in?
Yes.
Okay, 1 and what?
48.
Good. 2 go in?
Yeah.
Ah, okay. 2 and what?
4.
Yeah, that's right. Does 3 go in? Add these together.
Yeah, no, wait.
What's 4 plus 8?
12.
3 go into 12? Yeah, it does.
Yeah.
So 3 goes into this. 3 goes in how many times?
4 times? Wait, what?
Let's try. Ready?
Oh, 8. Wait, no, not 8. What
3 goes into 4.
1.
Okay. Then we subtract.
1.
3 goes into 18.
6 times.
So what's our number?
16.
Good. 3 and 16. Does 4 go in?
Yes.
How many times? 4 goes into 4. 4 goes into 4 how many times? Yeah. Subtract. Bring down the 8. 4 goes into
8. Twice.
what's our number?
12.
Good. Does 5 go in?
No.
Why not?
Because the ones column doesn't end in a 0.
Good. Does 6 go in?
Yes.
Why?
Because 2 and 3 go in.
Okay, so we got to test this. So 6 goes in. Let's figure out how many times. How many times does 6 go in the 48? And this is a really important one.
8 times.
8 times, that's right. Now, I want you to think about this, okay? This is a great example. See what number we got to? 6 times what? 8. As this increases, if you notice, we started at 1, this was really high. 2, this came down. 3 went down to 16. 4 went down to 12. 6 went down to 8. We knew we had to get to 7. If we were to test 8, well, it would be 8 times 6. And do you see how we're repeating those numbers again? Okay, that's how we know that's our middle point. Once we've tested the 7, we're okay to go.
Okay.
That's a tough idea.
Wait.
Let's repeat it one more time. So, I want you to look at our pairs. Our pairs are what's important here. So, 1 and 48, very extreme. Then when I went to 2, okay, we went, think of this as our first terms, okay? And okay, I'll match all our pairs up, and I'll call them first terms. So these are, I'll call them first terms. I'll call them the ones, okay? So if you notice, our 1 terms are getting bigger, right?
Yeah.
Okay, so we had 1, then we went to 2, then we went to 3, went to 4, went to 6. That's the number we're testing. As that happens, our first terms, and I'll put ST so we know they're first. What about our second terms? What's happening to them? What's happening to these terms? Went from 48 to... Yeah, so what's happening? It's decreasing. Now watch how rapidly it decreases. 24, then we went to...
16,
Then to...
12,
Then to...
8.
What would the next one in the pattern you think be? And there really isn't a pattern, but look. Oh shoot, that's not what I want. See how our first term was 6? We're getting higher and higher. So we're eventually getting to a point where we're going to flip now. Our first term, the next one over, will be larger than our second term. The next pairing would technically be 6 and 8. And see, that's where our first term got higher and our second term gets lower. But do you see how we flipped now? We're now repeating terms we've already used.
Oh, yeah.
Does that idea kind of make sense? So we don't want to repeat terms. That's why we use this little trick. It tells us really what's our final number we have to test for.
Okay.
Okay, does that make sense?
Yeah.
And then what type of number is this in the end?
Composite.
Good.
Wait, hold on. I just want to rewrite this. I'm ready.
Oh yeah, and we should put this in order for composite factors, right?
Yeah.
The factors are I'm going to write them in order. 1, 2, 3, 4, 6, and then we go 8. So it looks like we're almost going around the horn. If you look at it, we go 1, 2, 3, 4, 6, 8, 12, 16, 24. So we jump back up. It's like we go down the ladder and up the ladder. 8, 12, 16, 24, and 48. Okay?
The next one is 67.
All right. Well, you're going to try that.